Welcome back. Glad you could come. We are starting module 2 or chapter 2. This is part 1 of that, where we are going to be talking about frequency distributions. A frequency distribution, or I put the plural, shows how data are partitioned among several categories or classes by listing the categories along with the number or the frequency of data values in each of them. And I'm going to be basing everything. This is a frequency distribution. Here's the frequency, and then here's the range. This is all based on the data here. This data is wait times at fast food restaurants during a lunch. And these are in seconds, how long someone had to wait in a fast food restaurant. And this raw data is not very helpful. It's just a bunch of numbers. However, we can see that 11 people waited between 75 seconds and 124 seconds, and 3 people had to wait 225 seconds to 274 seconds. And so we can see how that's going to match up in there. So you can see one of these two is right here. There's the 308, right? That's going to be between 275 and 324. So this is our sort of base one that we're going to be using for a lot of what we're doing today. We have some more definitions. We have lower class limits. Are the smallest numbers that can belong to different classes. And to be clear, these are the lower class limits. So in there a little bit. So lower class limits is going to be like 75, 125, 175, 225, and 275. Next up are the upper class limits. As you probably already guessed, those are going to be the bigger numbers here. So here we have 124, 174, 224, 274, and 324. Next up, we have the class boundaries. Class boundaries. Now you'll notice, a little too high there. You'll notice that there is a gap between 124 and 125. So what we do is we go 0.5 down, up here and 0.5 down. So what that's going to give us is the lower class boundary here. So I'm going to go 0.5 down. So that's going to be 74.5. Then up by 0.5. So 124.5. And you'll notice if I go down by 0.5, it's also 124.5. And that's the point. That's getting these two to connect. Next one is going to be the 74.5. And notice if I go down 0.5 for this one, that's also 174.5. 224.5. Again, go down 0.5, it's the same. And we have 274.5, which is the lower one down here as well. And then here we have the 324.5. And we'll talk more about those when we get to the graphs of these called histograms. Class midpoints. Class midpoints is going to be the middle number here. And the way we calculate that out, it's values in the middle of each class, is I'm going to take the lower and the upper and add them up and divide by 2. So I'm basically taking the average. So 75 plus 124 divided by 2. So there it is, 99.5. And we'll talk more about what to do with these as well. Next up, I have 174 plus 125 divided by 2. That's 149. 0.5. Here I have 175 plus 224 divided by 2. The 399 divided by 2 is 199. 5. Here I have 225 plus 274 divided by 2. So 249. And you might start to see patterns as you're doing this, which is fine. 275 plus 324 divided by 2, 299.5. Those are the class midpoints. And our last definition here is the class width. Class width is the difference between two consecutive lower class limits. So if I take 125 and subtract 75, that's going to give me my class width. So 125 minus 75 is going to give me 50 is the class width. And we will definitely use the class width as we do this. This is how we find the class. We already have a frequency distribution table. If we don't, and we just have the raw data, then we have a different way of figuring that out. All right, next up, how to construct a frequency distribution table. I'm going to show you how to use your calculator for a moment. If you don't have the same type that mine is, that's okay. It's probably going to be a similar one. And if it's totally different, then you may need to look things up on YouTube to see how to do what I'm about to show you. So what I'm going to do is I'm going to hit stat one. Let's back up a second here. Here, our example, these are the heights in inches of commonly grown herbs are listed here. And they tell us they want us to make a frequency distribution table with 6 classes. We'll come back to that. First thing I need to do is take this raw data and put it into my calculator. Let me show you how I'm going to do that. I'm going to hit stat, and I'm going to edit my list. Now, to save time, I've already put this data into this list here. So those of you watching this video, you may want to pause it and actually put it in. Let me show you how you put data in. So let me just get that up. So 84, enter, 61, enter, and so on. And so that's how you put data in. Now, if you want to clear a list, which I encourage you to do before each one, is you go up, in this case to L2, hit clear, and hit enter, and it clears the list for you. That'll become very handy. Well, we want to make sure we don't have extra data in a list accidentally. Now, you'll notice my list that I have here, which is this data here, it's not in order. I need to put it in order. So for this calculator, what I'm going to do is I'm going to quit out of it, second quit. I'm going to go to stat again. And I have 2 ways of sorting my lists. Ascending order is going to be from smallest down to the biggest. Descending order will be the other way around, be biggest to the smallest. I want to sort in ascending order. Scooch that up a little bit. And my data is in list 1. You can see above my number 1, it says, mine's in blue, it says L1. That's my list 1. So to access that, I have to hit second and then L1. And then that puts list 1 there for me. And so when I hit enter and I go back to my list, it's now in order. You can see the smallest one was the 7, right? Then 10, 10's there, and so on. So now that they're in order, that's going to make things a little bit easier. We'll come back to that, and we'll use that in just a moment. Let's start with our first step. First step is to get the data into your calculator. After we do that, so now we're going to find the class width. Now you'll notice on the previous page, we found the class width, but we already had a frequency distribution table. So we just subtract the 2 lower boundaries. Here we just have raw data. And the way we calculate that is we take the largest data value. Now here's the good thing. I can go to the up and then up again. So that's going to be 36. So class width is going to be 36 minus the smallest data value. If I hit down, it takes me to the top of the list, which is 7, divided by the number of classes. And you'll note they want 6 classes. So let's see what we have going on. Second quit. 36 minus 7 divided by 6. Now you'll notice we didn't get a whole number, which is fine. So that's about 4.83. And here's the thing that we need to remember. We always need to round up. So what's the class width? It's going to be 5. That's going to be quite relevant here. So we're going to start. This is our height. This is our frequency. And there are going to be 6 classes. One, two, three, 4. 5, 6. All right, here's where we start. I'm going to start with the smallest number in my data set. If you remember, that was 7. Now, it may not, there may be a problem where they don't tell you to start with the lowest data number. They may say start at 5 or something, even though it's not the lowest. You can, either way, I prefer the way that I'm showing you to do this. Now I'm going to do this. I'm going to find out all the lower class boundaries. Well, the first one's 7, and I know to get the next one, I have to add 5. That's my class width, right? 7 plus 5 is 12. Five plus 12 is 17. Seventeen plus 5 is 22. 22 plus 5 is 27. 27 plus 5 is 32. All right. So we have our lower class boundaries. And we're going to find the upper class limits. Now, if this one starts at 12, that means this one ends at 11. If this one starts at 17, that means this one ends at 16. And you can see how I'm doing that. Now you'll notice this is also plus 5, plus 5, plus 5, plus 5, and so on. So this here, this here. And again, I'm just going to add 5 to that to get the 36. There we are. And now we're going to do our frequencies, and that we do this. I'm going to go back to my list that's been sorted. How many of them are between 7 and 11? See, it looks like there's 1, 2 of them are. 7 and 10. So there are 2. Next up, between 12 and 16. That's 1, 2, 3, 4, 5. Ooh. 5. Let's see. That was here. 1, 2, 3, 5. Next up, between 17 and 21. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 9. Between 22 and 26, 24 is definitely between there. So 1, 2, 2. And between 27 and 31, can you see there are none? It goes from 24 to 36, so there are 0. In between 32 and 36, there is exactly 1. There is our first frequency distribution table. Now, in real life, of course, you can decide how many classes there are and so on. And you can design any way you want to. It is better if they have the same width as you're going through and try not to mess with that. There may be reasons sometimes to mess with the widths. All right. And we have some variations on this. And I'm using the same distribution that we had there. And we are now to a variation of a basic frequency distribution. Frequency distribution. And it's sometimes called a percent distribution. In which each class frequency is replaced by a relative frequency or a percent. And what I'm going to do is we are going to extend this a little crooked there. It's okay. And this is going to be relative frequency. And what I'm going to do is I'm going to total these up. 11 plus 24 plus 10 plus 3 plus 2. So there's 50 total. And I'm going to take this and turn 11 over 50 into a percent. So 22%. This one's 24 over 50. 48%. 10 over 50. 20%. 3 over 50. 6%. 2 over 50. 2 over 50. Is 4%. Now these all came out nice and pretty whole numbers, which is fine. But you'll note if I add up all these percents, it should be 100%, of course. Another variation is a cumulative. Distribution. So we're going to find a cumulative distribution. Now I can't just tack on another column like this. I need to rewrite it. So this first one. We have 1, 2, 3, 4, 5 classes. This is going to be time 1, 2, 3, 4, 5. I need 2 more. Ooh. So 1, 2, 3, 4, 5. That'll work. So this is once again time, and this is the cumulative. So the way we write this out is we write it as less than 125, less than 175, less than 225, less than 275, and less than 325. So how many of them are less than 125? Well, 11 of them are less than. So this is 11. How many are less than 175? Well, here's 175. How many are less than? That's going to be 24 plus 11, which is 35. Less than 225, that's going to be 10 plus 24 plus 11, which is 45. Less than 275, that's including here, so 3 plus 10 plus 24 plus 11 is 48. And less than 325, that's all of them. That's 2 plus 3 plus 10 plus 24 plus 11, which is 50. And we already know that it should be 50, right? So you don't need to write all these pluses in there. I just wanted to show you where the numbers were coming from. So a nicely drawn one would say 11, 35, 45, 48, and 50 in that column there. And the last part for this video is we're going to introduce something called a normal distribution. A normal distribution is a distribution where the majority of the information is in the middle, and then it kind of gets smaller and smaller as we go to the extremes, the really small, the really big. And you can see for this one with the 30 in the middle, it has a much larger amount, and then it drops down lower and then drops down lowest. And we end up with a graph that looks like this, which we'll talk more about later. And this is called a bell-shaped curve or a normal distribution. We'll talk more about all that a little bit later.